Okay, let's pull back the curtain on one of the most important but totally invisible rulebooks of the internet, API rate limits. You can think of them as these digital guardrails that keep all the services we use every single day running smoothly. We're about to see exactly how they do it. You know that feeling, right? You're trying to refresh your feed or maybe check the weather, and the app just hangs. It spins for a second. Well, more often than not, the reason behind that little pause is the exact system we're going to break down today. So before we can even talk about the limits, we got to understand what's actually being limited. The best way to think about an API is to imagine it's a waiter in a restaurant. Your app is the customer. Now, your app doesn't just barge into the kitchen to get what it wants. That would be total chaos. Instead, it gives its order to the API, our waiter, who then goes to the service's kitchen and brings back exactly what you asked for. Now, just picture that same restaurant, but it's a Saturday night. It's packed. If every single person in the city tried to order at the exact same moment, well, the kitchen would just get completely overwhelmed. Service would grind to a halt. Nobody would get their food. And you know what? The exact same thing can happen on the internet. And this is where our solution comes in. An API rate limit is kind of like the restaurant's maître d'. It's the person at the front door managing the flow of orders, making sure the kitchen can actually handle the load. It's not there to stop you from getting served. It's there to make sure everyone gets served in a nice, orderly fashion. So why even have these rules? I mean, why can't every app just request whatever it wants, whenever it wants? Well, because these limits are pretty much the only thing standing between a functional internet and complete digital chaos. And I mean, just look at all the reasons why. It's not just one thing. Rate limits act as a shield against malicious attacks, like denial of service. They guarantee fair access, so one super popular app can't just hog all the resources. They help companies manage their server costs, which are very real. And they even push developers to write smarter, more efficient code in the first place. Okay, now here's a really key thing to understand. Not all requests are treated the same. Just like in that restaurant we were talking about, the API service kind of has a VIP section. It gives more access to the users it knows and trusts. First up, you've got the anonymous user. This is like someone just peering in the restaurant window. The API has absolutely no idea who they are, so it gives them the most restrictive limits. It's really just a matter of trust, or in this case, a complete lack of it. And to make this really concrete, let's look at GitHub's public API. If you make a request without identifying yourself, you are limited to just 60 requests per hour. That's it. It's a really clear signal, hey, we don't know you, so please don't overwhelm us. But what happens when you log in? Well, now you're not a stranger anymore. You've basically made a reservation. By providing a key or logging in, you've identified yourself to the API, and that single act builds a crucial layer of trust. And just look at the difference that trust makes. An authenticated user on GitHub can make up to 5,000 requests per hour. We just jumped from 60 to 5,000 simply by proving who we are. That is a massive, massive increase. I mean, this chart really says it all. You can see that tiny little bar for the anonymous user at 60, then this huge jump to 5,000 for a logged-in user, and then an even bigger leap for a professional application, maybe something like 15,000 requests an hour. It couldn't be clearer. Identity really, really matters. But wait, it gets even more sophisticated. See, modern rate limiting isn't just about counting how many times you knock on the door. It's also about how you're knocking. It's watching your behavior. So, beyond a simple hourly count, services might limit other things, like concurrency, how many requests you're making at the exact same second, or how quickly you can post comments, which is a great way to prevent spam. They might even measure how much of the server's brain power your requests are using up. It's a much, much deeper level of control. You know, a really clever way to handle this is with a point system. Not all requests are created equal, right? A simple request to just read some data might cost 1 point from your budget. But a really complex request to create new data, which makes the server work a lot harder, that might cost 5 points. It shows that it's not just about the number of requests, but also their weight. All right, so if you're a developer and you're building an app, how do you navigate all these rules? How do you build something that's powerful but also respectful of these limits?
Let's get into the practical side of being a good API citizen.
So, the first question is probably how does your app even know what the limits are or how close it is to hitting them? It can't just guess, right? Well, luckily, the API service communicates this information directly with every single response it sends back. It does this using something called HTTP headers. The easiest way to think of them is like a little sticky note the waiter attaches to your order. These headers tell your app everything it needs to know. Limit is the total you're allowed, remaining is how many you have left in your allowance, and reset is the exact time when your counter goes back to 0. And if your app ignores those headers and just keeps making requests, it gets a very clear message back, a 429 too many requests error. And this isn't a punishment, it's just communication. The API is literally telling your app, hey, you need to slow down for a little bit. So the best practices for developers are actually pretty clear. Step 1, and this is the big one, read the documentation first. Step 2, design your app to actually read those headers so it always knows its status. 3, if you do get limited, back off gracefully and just wait. And finally, be efficient. Cache data so you don't have to ask for the exact same thing over and over again. When it comes down to it, while they might feel like a restriction sometimes, rate limits are a fundamental part of what makes the modern internet actually work. They're what ensure fairness, security, and stability for this huge digital ecosystem that connects all of us. They're the quiet guardians keeping everything in order. And that kind of brings us to a final thought. We've just uncovered one of the internet's most important invisible rulebooks, and it really makes you wonder, what other complex, hidden systems are working behind the scenes right now, making sure our digital world doesn't just fall apart,